Hi everyone, my name is Janani Ravi and welcome to the Container Certification Guide. You might be asking, why containers? And to answer that, let's look at the characteristics of high quality software. To build a high quality system, first, your production system needs to scale to handle hundreds of thousands of requests. Second, your release cycles need to be super quick. Bug fixes and features should be available to customers in a matter of days. Third, your development and deployment pipelines need to be automated to manage all of this in a sustainable manner. These are hard requirements. How do organizations achieve this? Well, a lot of meticulous hard work and the use of containers and container clusters. Today, containerization technology is at the heart of almost every large-scale, high-quality application. This means that understanding how to create, package, deploy, manage, secure and scale your applications using containers is a very, very important skill for any software engineer. Now I'm curious, why are you interested in getting a container certification? Are you a novice and you feel this is a good way to learn a new technology? That's a great reason, by the way. Or are you looking for a career change and you want to showcase your container skills to potential employees and stand out in a crowded field of potential recruits? A certification will definitely help there. Container certifications are a great gateway into working with deployments on cloud platforms as well. All major cloud providers have their own offerings for containers and container clusters. And in this video, we'll navigate and discuss the container certifications available to you. First, we'll talk about the importance of containers and container clusters. Let's look at three types of deployments. First is the traditional deployment, second, the virtualized deployment, and third, container deployments. These three types of deployments will allow us to understand why containers and container clusters help ease the pain of software development and releases. Back in the day, not so very long ago, we deployed software directly on machines or bare metal. Cloud platforms either did not exist or were not as widespread as they are today. Organizations bought machines, set up their data centers, and deployed their applications directly on those machines. Traditional deployment had a bunch of drawbacks. You had to have engineers administer and manage the machines as well as write and maintain the software, and this was a very heavy burden. There was no way to define resource boundaries for applications on a physical server, which led to resource allocation issues. A single application could hog all of the resources. This led to over-allocation of machines, which led to operational inefficiency. Also, apps built directly on top of the operating system were not portable, sometimes even across different versions of the same OS. With the advent of cloud platforms, though, came the era of software virtualization. Virtualization allows you to run multiple virtual machines, or VMs as they are called, on a single physical machine. Apps are much more isolated and thus more secure. Virtualization also abstracts the underlying hardware and operating system from your application using software known as a hypervisor. This makes your app more portable. Virtualization reduces the hardware costs and better utilizes hardware resources and passes off a lot of the machine management overhead to cloud platforms. Virtualization, however, did not help with all of the little details you have to worry about when you build an application. You still need to develop the code, specify the dependencies, install the dependencies, specify configuration parameters for the app, and a whole lot more. Also, VMs are still pretty heavyweight since they include the host operating system. And this is exactly where containers came in. Containers are software packages that bring together your application code, its dependencies, configuration, system tools, all into a single deployable unit. Containers are platform agnostic because they're abstracted away from the operating system by something we call the container runtime. Containers are small and lightweight. They don't include the OS, and this makes them easy to deploy and scale for large applications. The most popular containerization technology used today is Docker. So when people speak of containers, you can mostly assume that they're referring to Docker containers. However, you should know that there are other containerization technologies out there which are also used in different ecosystems. Technologies such as Podman, LXD, and Containerd. These are also popular. Running standalone containers is not really very useful. They cannot heal themselves if they crash. They cannot spin up more instances to meet additional traffic requests. They do not offer load balancing or traffic splitting. For all of this, you need a higher level orchestration of containers, which gets containers working together as a group. This is what container clusters provide. The most popular and widely used orchestration technology today is Kubernetes, also known as K8s. Here the 8 stands for the 8 letters between K and S in Kubernetes. Now, the cool thing about Kubernetes is that it can run on virtual machines on a cloud platform or on bare metal machines in an on-premises data center, which means that Kubernetes allows organizations to operate in a hybrid multi-cloud world. Organizations increasingly do not want to be dependent on a single cloud platform. Vendor lock-in is a serious risk. Organizations may also want to run their applications on the cloud as well as on their own data centers for the purposes of risk and disaster management. Kubernetes offers a middle ground between infra as a service options at one end of the spectrum and platform-specific platform as a service options at the other end. All the major cloud platforms such as AWS, Azure, and the Google Cloud Platform support Kubernetes, which means that getting certified for running containers on Kubernetes clusters is a great stepping stone to working on any of these cloud platforms. The container certifications that we'll discuss today lay the foundation for a variety of roles: full stack developer, DevOps engineer, release engineer, and automation engineer, just to name a few. Here is what the container certification landscape looks like today. I'll first be talking about the Docker Certified Associate certification and then a number of different certifications offered by the Cloud Native Computing Foundation. The visual here is just a quick look at the 5 different certifications that I'll discuss in this broad area. Once we've discussed these certifications, I'll briefly cover some container certifications specific to the Red Hat Linux ecosystem. There are 3 Red Hat certifications which we'll discuss today that will help you gain expertise working with the OpenShift container platform and Kubernetes. Let's start with the Docker Certified Associate or the DCA exam. When you first start researching container certifications, you may come across a certification exam called the Docker Certified Associate or the DCA. This certification was first launched in 2017 and covers a lot of core containerization concepts. The DCA is often the first certification learners try to obtain when they start their container journey. This entry-level certification targets professionals who have worked with Docker and Kubernetes for about 6 to 12 months, and this certification focuses on containers rather than container clusters. Specifically, this certification covers Kubernetes orchestration with image creation, management and security, installation and configuration of containers, container networking, container security, storage and volumes. When you look into this exam, you might be thinking, wait, who is this exam made by? The DCA was originally offered by Docker, the company which created Docker containers. Docker was then bought over by another software company named Mirantis in 2019, and now this certification is offered by, yep, you guessed it, Mirantis. You can learn more about the DCA and view some sample questions in the linked resources below. With all that said, there are thoughts in the community that this certification is no longer as relevant as the other certifications have superseded it. If you still choose to sit the certification exam, here is a quick overview. The DCA certification exam is a 90-minute exam with a total of 55 questions, 13 multiple choice questions and 42 discrete option multiple choice questions. If you're an absolute beginner and have never worked with containers before, this certification will definitely help you. This is the only certification that has more of a focus on Docker containers and commands, and you'll find that other certifications tend to take Docker containerization a little bit for granted, and they focus on deploying containers on Kubernetes. So if you have the time and you want to ensure that you have a solid understanding of Docker before you move on to Kubernetes, then this certification is totally worth it. However, as I said earlier, this certification has been superseded by other certifications that I'm about to talk about. So if you're already a Docker practitioner and familiar with Docker commands and configurations, this certification may not hold that much value for you. Now let's talk about the Linux Foundation and the Cloud Native Computing Foundation. We'll look at the Kubernetes certifications offered jointly by the Linux Foundation and the Cloud Native Computing Foundation, or CNCF. The Linux Foundation is a non-profit technology consortium founded in 2000. It's been around for a long time. It focuses on standardizing and promoting the growth of the Linux operating system through events, training, certifications, including Kubernetes-focused certifications. The Cloud Native Computing Foundation, or CNCF, was founded in 2015. It's more recent, and it was founded by the Linux Foundation. Google originally developed an open source Kubernetes, but then handed over operational control of Kubernetes to the CNCF in 2018. The main objective of the CNCF is to advance container technology, which means that any certifications by the CNCF are considered to be state-of-the-art and highly relevant. So let's take a look at the Kubernetes-related certifications offered by the Linux Foundation and the CNCF. This visual here should give you a quick overview. The first thing you should be aware of is that these certifications expect that you're familiar with the Linux ecosystem and you know how to create, register, and deploy Docker containers. Why? Because they're assuming that you're aware of the concepts and fundamentals covered in the Docker Certified Associate exam. And so if you're a containers novice, then these certifications would be the second stop in your container certification journey. The first stop amongst the CNCF certificates is the Kubernetes and Cloud Native Associate, or the KCNA. This certification serves to demonstrate a learner's foundational knowledge and skills in Kubernetes and the cloud native ecosystem. This is often the certification you ought to take first before you jump into other CNCF certifications, either on the development track or the administration track. Once you have the basics of Kubernetes covered, you can then choose what track you want to be on. If you're a developer or a DevOps engineer writing code for applications and you want to know how best to use Kubernetes to deploy and scale your applications, the certification on the developer track is the right one for you. The Certified Kubernetes Application Developer, or CKAD. On the other hand, if you are an administrator or an automation engineer working in operations or a security-focused role, you might find that the certifications on the administrator path are more relevant for you. You'll start off with the Certified Kubernetes Administrator, or the CKA. If you want to dive deeper, then you can take the Certified Kubernetes Security Specialist, or the CKS certification. Just note that the CKA is a mandatory prerequisite for the CKS. Let's start by looking at each of these certifications in turn, and we'll start with the Kubernetes and Cloud Native Associate. The KCNA certification is what the CNCF terms a pre-professional certification, and so is considered beginner level. This certification serves to show that you know something about working with Kubernetes, but you're not really beyond the basic concepts and a high-level understanding. Now, this certification alone may not help you that much, but this is a great starting point if you want to tackle the other CNCF professional certifications. One thing to note, this is a brand new certification launched in 2021. Now, this certification is primarily meant for students or learners who are just getting started with containers and Kubernetes and working on cloud native technologies. The idea behind this certification is to equip learners with the right foundational knowledge for other CNCF credentials. Now, this certification is also the right one for you if you're in a role where a high-level conceptual understanding of Kubernetes and cloud-native applications will help you, such as product management, engineering management, technical leadership, or even a marketing role. You may not be working hands-on with Kubernetes on a day-to-day basis, but you feel that Kubernetes fundamentals can help you make the right long-term decisions about your product. Now, this exam is an online proctored multiple choice exam. In fact, this is the only certification in the CNCF suite that is multiple choice. You'll find that all of the other certification exams are hands-on. The main domains covered by this certification are Kubernetes fundamentals accounts for 46% of the exam, container orchestration 22%, cloud native architecture 16%, cloud native observability 8%, and cloud native application delivery another 8%. A large part of the certification exam focuses on Kubernetes fundamentals, its architecture, resource and APIs, as well as containers and scheduling. Under container orchestration, you'll find that you will need to understand how the container runtime, security and networking functions work. This portion will also include the service mesh and storage in containers. The cloud native architecture portion includes autoscaling and serverless containers and the creation and configuration of roles and personas on container clusters. The monitoring and observability domain includes using the Prometheus tool and cost management. And finally, the application delivery section covers GitOps, CI/CD pipelines for automated delivery of software using Kubernetes. Now, if you're comfortable building and deploying cloud native applications and are a competent user of Kubernetes, you may choose to skip this certification altogether and go directly to the professional certifications, either the developer or the administrator paths, and these carry more weight. However, if you're new to cloud native and Kubernetes development, I would highly recommend this certification, the KCNA, to build up your resume and your confidence in tackling the more advanced certs. Next, let's talk about the Certified Kubernetes Application Developer, or the CKAD. This is a CNCF professional certification. Professional meaning meant for engineers responsible for actually building, deploying, and configuring cloud native applications with Kubernetes. Now, if your dream role is that of a full stack developer and you're looking to build and deploy applications at scale on Kubernetes, this is the right certification for you. This certification focuses on application development and deployment on Kubernetes rather than administration. So if you're a developer on a team using Kubernetes but are not responsible for administering and managing a Kubernetes cluster, choose the CKAD certification. Now, mind you, this is an advanced certification. It's assumed that you're well versed with core container and Kubernetes concepts covered by the previous certifications that we've discussed. This certification also assumes working knowledge of the container runtime and the microservice architecture. So it is helpful if you've had some real-world experience building and deploying production-ready pipelines. Now, this certification is an online proctored exam, but it's not multiple choice. It's a performance-based test. It gives you a set of 15 to 20 problems that you need to solve using the command line, all within 2 hours. So you actually have to complete tasks in the right manner using the right set of commands and configurations. The exam allows you to access certain permitted online sites. There is a set mentioned online for all of these sites. You can use these sites to complete these tasks. When you register for the exam, you'll have 2 attempts to practice with an exam simulator provided by killer.sh. Given that this exam is real time, it's worth your while practicing common operations using the command line to ensure that you're very familiar with the basic structure of various commands. Now, here are the broad topics covered by the certification. Application design and build, that accounts for 20%, application deployment another 20%, application observability and maintenance 15%, application environment configuration security another 25%, and services and networking account for the last 20%. Application design and build covers defining, building and modifying container images, running jobs and cron jobs on Kubernetes, using multi-container pod designs such as sidecar, init and others, and using persistent and ephemeral volumes with containers. Application deployment covers common deployment strategies, using deployments for rolling updates and using the Helm package manager for deployments. The observability and maintenance domain tests the use of probes and health checks and the use of logs and tools to monitor and debug Kubernetes applications. The application environment configuration and security domain covers authentication and authorization to Kubernetes clusters, defining resource requirements, limits and quotas, using secrets and service accounts and security context to secure your applications. And finally, the services and network domain includes configuring network policies, configuring ingress rules to expose applications to the external world. As you can see, these are a fairly wide-ranging set of topics which cut across different areas in application development as well as deployment. This certification is hard. There is no getting around that. But if you pass, it's a real asset on your resume. It makes you more attractive to employers and get you hands-on experience with the job that you'll be doing. The Certified Kubernetes Administrator or the CKA is another Kubernetes professional certification meant for system and cloud administrators who are responsible for managing instances on Kubernetes clusters either on premises or on a cloud platform. Now, this is the first certification on the administrator path for Kubernetes. If you plan to develop Kubernetes applications, that is, write code that will be containerized and deployed to Kubernetes, the CKAD, which we discussed earlier, is a better fit. But it's possible that you don't write code but are responsible for configuring and securing clusters. If that's the case, the CKA is the right certification for you. This certification assumes that you have basic knowledge in working with containers and Kubernetes clusters. You'll definitely need to know the basics of some of the topics covered by the CKAD, but the main focus here is going to be managing the Kubernetes environment and configuring and securing the Kubernetes cluster using best practices. Once again, this is a hands-on exam, not multiple choice. During the 2-hour exam, you'll have access to a command line running Kubernetes and you will run commands to complete about 15 to 20 performance-based tasks. Again, when you register for the exam, you'll have 2 attempts to practice with an exam simulator provided by killer.sh. Here are the domains and competencies covered by this certification. Storage on clusters, that is about 10%. Troubleshooting clusters around 30%, workloads and scheduling account for 15% of the exam, cluster architecture, installation and configuration accounts for another 25%, and then services and networking is the last 20%. As you can see, there is some overlap in the topics covered by the CKAD. For example, services and networking is a common domain across both. But in this certification, there is no emphasis at all on the best practices of application design, deployment, monitoring, etc. Because this certification has less to do with applications deployed on the cluster and is more about the cluster itself. The focus is on ensuring that the cluster is healthy, configured correctly, and secure. Storage covers the use of storage classes and persistent volumes, configuring applications that use persistent storage, setting volume access modes, and reclaim policies. The troubleshooting domain involves topics such as monitoring applications, evaluating cluster and node logging, and troubleshooting application failures, networking, and cluster component failure issues. Workloads and scheduling covers deployments, rollbacks, rolling updates, using the right primitives for auto-healing, scaling deployments, and scheduling pods. The cluster architecture installation and configuration domain involves provisioning infrastructure for clusters, configuring and upgrading clusters, managing access using roles, cluster backup and recovery. And finally, services and networking covers connectivity between cluster nodes, between the pods on a cluster using the right endpoint for your services, using ingress controllers and ingress resources. If you're looking to upskill as an administrator of cloud-native deployments, then this is the right certification for you. The CKA exam is a mandatory prerequisite for the Certified Kubernetes Security Specialist, which we'll discuss next. So let's move on to the CKS, or the Certified Kubernetes Security Specialist. Now, of all the exams offered by the CNCF, this is by far the most advanced of the professional certifications. Before you sit for this exam, an essential prerequisite is that you have an active, that is a non-expired CKA certification. As the name suggests, this exam goes beyond basic cluster administration and focuses on the application of best practices for securing container-based applications on Kubernetes during build, deployment, and runtime. If you're a highly skilled Kubernetes administrator, this exam can set you apart in any recruitment process. Security is increasingly important in today's world, and it's only going to get more important in the future. Going beyond administration and including security in your skill set is a clear upward professional step that will allow you to move to the next level in your career. Once again, this is a hands-on, online, proctored, performance-based test where you have to complete a number of tasks in 2 hours using the Kubernetes command line. Here are the domains and topics covered in this exam. Cluster setup accounts for 10%, cluster hardening 15%, system hardening another 15%, minimizing microservice vulnerabilities, that's 20%, supply chain security another 20%, and monitoring, logging and runtime security accounts for the last 20%. Cluster setup, amongst other tasks, focuses on the security configuration of Kubernetes components, restricting cluster level access, restricting access to GUI elements, and verifying the binaries that you deploy. Cluster hardening includes configuring role-based access control to minimize API exposure, minimizing permissions on service accounts, and Kubernetes upgrades. The system hardening domain includes reducing the attack surface of the host operating system, minimizing identity and access management roles and external access to the network. This portion also covers the use of kernel hardening tools such as AppArmor. Minimizing microservice vulnerabilities deals with security domains, managing Kubernetes secrets, pod-to-pod encryption, and using container sandboxes in multi-tenant environments. Supply chain security focuses on the container image footprint, whitelisting signed and validated images and scanning images for vulnerabilities. Monitoring, logging and runtime security involves analyzing process and file activities to detect malicious access, detecting phases of an attack, detecting threats to infrastructure, ensuring immutable containers and other security investigation-based topics. This certificate, as you can tell, is no walk in the park. It's definitely an advanced exam. However, if you want to set yourself apart and not be a yaka, that is yet another Kubernetes administrator, this is the certification for you. As you might have noticed, the CNCF certifications focus on Kubernetes and cloud-native architecture. They are not specific to any one cloud platform. But gaining expertise in Kubernetes can help you transition to working with Kubernetes on any of the big 3 cloud platforms, AWS, Azure, or the GCP. The architect and DevOps certifications on these platforms often have Kubernetes as a core requirement. In addition, if you're interested in microservices frameworks and certifications based on these frameworks, a foundational understanding of Kubernetes is a real asset. Now that we've seen the container-based certifications offered by the Cloud Native Computing Foundation, let's turn our attention to a slightly different universe. Red Hat is a software company that is a leading provider of enterprise software solutions built using open source products. Their enterprise products included high performance Linux. You've probably heard of Red Hat Linux. They also offer enterprise products for container and Kubernetes technologies. Companies across the world use Red Hat products, which means if you're planning to work on container clusters in the Red Hat ecosystem, you should definitely consider the container-focused Red Hat certifications. Red Hat has its own family of containerization products that it develops and maintains called OpenShift. The flagship product in the OpenShift family is the OpenShift Container Platform, an on-premises platform as a service built around Linux containers, orchestrated and managed by Kubernetes, installed on a cluster of machines running Red Hat Enterprise Linux. It's Kubernetes at its core, but it has a number of services and features that are unique to Red Hat, and these features may work differently from open source Kubernetes. One thing to keep in mind, Red Hat uses Podman as a containerization technology and not Docker. So any experience that you have with Docker will help, but may not be directly useful. If you head over to the Red Hat certifications page, you'll find a huge list. They have certifications for all their enterprise products. The 3 specific certifications that we are going to be discussing are the ones focused on containers and container clusters. Here is a roadmap for the Red Hat container-based certifications. Even though I've marked dependencies between certifications, you should know that these are very loose dependencies and not strict requirements. These loose dependencies are shown by the dotted lines between the certifications. For example, you could choose to take the Red Hat Certified Specialist in Containers and Kubernetes alone, without doing the OpenShift Administration or OpenShift Application Development certs. Please note that you do need to be aware of how OpenShift works in order to pass the certification on containers and Kubernetes in Red Hat. The first certification in this series, the Red Hat Certified Specialist in OpenShift Administration, targets IT professionals who are looking to administer the OpenShift container platform. If you already happen to have a Red Hat Certified Systems Administrator certification, then you have the right background to tackle this exam. This exam will demonstrate that you have the ability to manage the OpenShift container platform, manage users and policies, control access to resources, manage networking and applications, schedule pods, deploy and scale your application. If you're looking for a system administrator or a DevOps role in an organization that uses Red Hat OpenShift containers, then this is the right certification for you. Next, let's discuss the second certification in this series. If you happen to be an enterprise application developer rather than an administrator and you're looking to work with Red Hat OpenShift, the right certification for you would be the Red Hat Certified Specialist in OpenShift Application Development. This focuses less on administration and more on the process of creating containerized applications, building and deploying these applications, monitoring application health, and porting existing applications to the OpenShift container platform. If you want to move beyond the basics in OpenShift administration and application deployment, you can choose to take the Red Hat Certified Specialist in Containers and Kubernetes. This approaches the OpenShift platform from the point of view of an architect, where you understand the container and OpenShift architecture and you create containerized and multi-container applications on OpenShift. As I had mentioned earlier, the other certifications are not strict prerequisites for this one. You could definitely tackle this certification standalone as long as you're familiar with working on the OpenShift platform. Now let's talk about where you will find the resources you need to prepare for these certifications and what you should focus on in your preparation. For the CNCF certifications, you'll find a whole host of resources online. The KCNA, or the Kubernetes and Cloud Native Associate, is a brand new certification launched in 2021, so there aren't that many online resources that are geared towards the certification exam just yet. I'm sure that'll change very soon. However, since this certification covers the basics of Docker and Kubernetes, you could just use online courses and documentation that teach these technologies, and you'll be well set for this exam. I'd like to mention that Cloud Guru and Pluralsight have a number of courses on getting started with Kubernetes that will set you on the right track. I've listed some courses that I think will be relevant for you in the resources. Even though the certification is not hands-on, I recommend getting a bunch of hands-on experience. That will help you really internalize the concepts that the certification covers and will prepare you nicely for the professional certifications. For the professional certifications, which have been around for a while, namely the CKAD, the CKA and the CKS, you'll find several very high quality training resources across different sources. I would highly recommend the courses on Cloud Guru, but you'll find that the Linux Foundation and the CNCF also offer a number of great resources that are geared towards these certifications. A reminder, these are hands-on exams, so make sure you spend most of your time doing labs and getting a feel for the commands you must run on the command line. Also, make sure you get used to navigating, searching and using the permitted Kubernetes documentation sites. This will save you time in the exam. You don't need to memorize commands, but if you run the commands before during practice, you will know how to construct these commands quickly during the exam, and that will help tremendously. For the Red Hat certifications, by far the best resources are the training materials provided by Red Hat themselves. They offer extensive courses and will point you to the right resources for each certification exam. Now, these training materials tend to be a little expensive, but if you're interested in the Red Hat OpenShift certification, it's quite likely that your organization is already using Red Hat OpenShift. So it might make sense for you to approach your company to see if they're willing to invest in your training. I know I mentioned this earlier, but knowing how to work with Kubernetes sets you up nicely for Cloud Architect and DevOps based certifications on all three major cloud providers, AWS, Azure and the GCP. As you prepare for your certifications, remember that active hands-on learning is key. Memorization and study of concepts can only take you so far. When you actually build and deploy containerized applications in a hands-on manner, you remember the little tricks, the small details and the nitty-gritty involved. Active hands-on learning is slow and sometimes painful, but there is absolutely no substitute for it. If you're looking for some practical opportunities, then I've added a link to the Kubernetes-focused hands-on labs at Cloud Guru. However, no matter how you get practice, you'll see the results when you pass the certification exams and land your dream job. It's time for me to say goodbye. I hope you found the certification guide useful and that it helps you find the right certification for you. If you've already passed any of these certifications and have additional tips and tricks for other learners, please do share them in the comments. In the meantime, goodbye and keep on learning.